In the world of data analysis, generative AI has emerged as a powerful and efficient ally. But even the most sophisticated AI can sometimes produce code that doesn't quite hit the mark. Imagine you've tasked your AI assistant with generating a script to analyze customer data, but when you run it, you're greeted with a perplexing error message. Suddenly, the seamless flow of your analysis grinds to a halt, leaving you with a puzzling challenge to overcome. Welcome to the world of debugging AI-generated code, where you embark on a quest to uncover the root cause of errors and restore order to your analysis. But you have a powerful toolkit of debugging techniques at your disposal. You can use print statements to trace the flow of your code, like following breadcrumbs through a forest. For example, if you're calculating the total sales for a specific product, you might print the intermediate results at different stages of the calculation to ensure they're accurate, or pinpoint where the calculation is going astray. Breakpoints allow you to pause the execution of your code at specific points, giving you the opportunity to examine variables and step through the code line by line, like a detective carefully analyzing each clue. In the total sales calculation example, you might set a breakpoint at the beginning of your loop to examine the very first calculation and make sure your code is starting off on the right foot. And logging tools provide detailed records of your code's behavior, offering a historical perspective that can help you identify patterns and anomalies that might point to the root cause of the error. AI may be able to assist in troubleshooting the code as well. If you have issues with Gen AI code, you can tell it in plain language, "This is not working," and ask it to please add some print statements and breakpoints. With patience, persistence, and a methodical approach, you can unravel the complexities of the error and get your analysis back on track. Debugging AI-generated code is not just about fixing errors. It's about deepening your understanding of the code, honing your problem-solving skills, and becoming a more proficient data analyst. So the next time you encounter an unexpected error, don't let it discourage you. Embrace the challenge and leverage your debugging tools so you can navigate the complexities of your code with confidence.
Let's explore common problems in AI-generated code, understand why they occur, and most importantly, equip you with strategies to identify and rectify them effectively. By the end of this video, you will be able to explain frequent issues like syntax errors, logic flaws, and data type mismatches that can arise in AI-generated code. Let's begin with syntax errors. Imagine syntax as the grammar of a programming language. Just like a grammatically incorrect sentence can disrupt communication, a syntax error can hinder the execution of your AI-generated code. These errors often manifest as typos, incorrect punctuation, or missing brackets. While they might seem trivial, they can completely stop your analysis progress. You might wonder why AI, with its vast knowledge, would generate code riddled with syntax errors. Well, AI models, while incredibly powerful, are still learning the nuances of different programming languages. They might occasionally misinterpret your instructions or fail to grasp the specific syntax rules of a particular language. Your initial approach to avoiding syntax errors is to carefully review your code. Take the time to meticulously examine the AI-generated code, looking for any inconsistencies or deviations from the expected syntax. Additionally, use code editors or integrated development environments, or IDEs, that offer syntax highlighting and error checking features. These tools can automatically flag potential syntax errors, saving you valuable time and effort. Next, let's navigate logic flaws. Logic flaws, unlike syntax errors, might not prevent your code from running, but they can lead to inaccurate or unexpected results. These errors stem from incorrect assumptions, faulty reasoning, or unintended consequences within your code. Consider a scenario where you're using AI to generate code for calculating the average of a dataset. The AI might inadvertently include null values in the calculation, skewing the final result. Or it might generate code that performs an incorrect mathematical operation, leading to an erroneous output. Identifying logic flaws requires a combination of critical thinking and thorough testing. Carefully analyze the AI-generated code step by step ensuring that it aligns with your intended logic. Pay close attention to any conditional statements, loops, or calculations. Once you're satisfied with the code structure, subject it to rigorous testing using a variety of input data. Compare the actual output with the expected output to uncover any discrepancies or inconsistencies. Finally, let's tackle the challenge of data type mismatches. In the world of data analysis, data comes in various types, such as integers, floats, strings, and booleans. A data type mismatch occurs when you attempt to perform an operation on data of incompatible types. For example, trying to add a string to an integer would result in a type mismatch error. AI models, while adept at understanding the context of your instructions, might not always perfectly infer the data types involved in your analysis. They might generate code that attempts to concatenate a string with a numerical value or perform arithmetic operations on textual data. To prevent data type mismatches, it's important to explicitly define the data types of your variables and ensure that any operations performed on them are compatible. Additionally, leverage the power of type checking tools or libraries that can automatically detect and flag potential type mismatches during code execution. Throughout your journey with AI-generated code, it's essential to embrace the debugging mindset. Debugging is not merely a task, it's a skill that empowers you to systematically identify and resolve errors in your code. When dealing with an error, don't panic. Instead, take a deep breath and take a calm and methodical approach. Start by carefully reading the error message, which often provides valuable insights into the nature and location of the problem. Use print statements or logging tools to track the flow of your code and identify the specific line or section where the error occurs. If you're unable to pinpoint the error immediately, don't hesitate to break down the code into smaller, more manageable chunks. Test each chunk individually to isolate the problematic area. Use online resources, forums, or communities to seek guidance and learn from the experiences of others. As you gain proficiency in identifying and resolving common errors, you'll be ready to explore more advanced techniques for enhancing the quality and reliability of your AI-generated code. Consider incorporating unit tests, which are small, isolated tests that verify the correctness of individual functions or modules within your code. Furthermore, explore the concept of code refactoring, which involves restructuring your code to improve its readability, maintainability, and performance without altering its external behavior. Refactoring can make your code more resilient to errors and easier to debug in the long run. Lastly, keep yourself updated on the newest developments in generative AI and data analysis tools. The field is rapidly evolving, and new techniques and best practices are constantly emerging. By staying informed and continuously learning, you'll stay ahead in this exciting field. Working with AI-generated code can be a transformative experience, but it's important to be aware of the potential pitfalls. Be aware of the common issues that can arise, such as syntax errors, logic flaws, and data type mismatches.
Welcome to a look into the topic of code debugging with generative AI. In this video, we'll go beyond code generation and explore how AI-powered tools can assist you in identifying and resolving errors in your code, ensuring its accuracy and functionality. We'll demonstrate how to effectively utilize code editors and debugging tools, like Copilot, to correct errors in AI-generated code. By the end of this video, you'll be able to describe debugging techniques to troubleshoot and correct errors in generated code. Even with the advancements in AI-powered code generation, errors can still get into your code. These errors can range from simple syntax mistakes to more complex logical flaws. Let's see how AI can help us in this debugging process. Let's begin by showcasing how VS Code can assist in identifying and highlighting potential errors in your code. Here we have a Python script with a few intentional errors. Notice how VS Code is already underlying some of these errors with red squiggly lines, even before we run the code. Let's hover over one of these underlines to see what VS Code suggests. A pop-up window appears and displays VS Code suggestion, Unexpected Indentation. Copilot Online can offer a clear and concise explanation of the problem with the following prompt: how to fix this Python code. It will suggest a fix, which we can apply in our editor. This real-time feedback allows you to quickly identify and address syntax errors or typos, saving you time and frustration during the development process. But Copilot's error detection capabilities go beyond simple syntax checks. It can also flag potential logical errors or inconsistencies in your code. For example, let's introduce an infinite loop in this script. We'll see if Copilot can catch it. Copilot can make suggestions such as, add a break condition to the loop, or removing this condition will fix the infinite loop. Copilot has flagged the infinite loop and is offering potential solutions to fix it. This proactive error detection can help you prevent runtime errors and improve the overall robustness of your code. Let's select one of the suggestions to fix the infinite loop. Now let's explore how we can leverage debugging tools to pinpoint and resolve errors that might not be immediately obvious. We will find a breakpoint in the code and click on the left margin next to the line of code. We can use breakpoints to pause the code execution at specific points and inspect the values of variables or the program's state at that moment. This allows us to go through the code line by line and observe how the data is being processed. Let's see how the code runs in debug mode. We can see that the execution pauses at the breakpoint. By carefully examining these values and the program's state, we can identify where things might be going wrong and trace the root cause of the error. In a debugging panel, we can use the controls such as step over in order to pinpoint the source of the error. In addition to breakpoints, we can also use logging or print statements to track the flow of execution and output intermediate values. This can be helpful in understanding the program's behavior and identifying unexpected values or logic branches that might be causing errors. Now let's run the code again with the print statements. Now, let's say in a new scenario, we've identified an issue where the calculated sum seems incorrect. We suspect there might be a problem with how the data is being processed within a specific function. Instead of manually combing through the code, we can leverage Copilot's code analysis capabilities to help us pinpoint the issue. We can simply copy the relevant code snippet, including the function in question, and paste it into Copilot Online, along with the description of the problem we're encountering. Copilot will then analyze the code, looking for potential logical errors, incorrect calculations, or any other issues that might be causing the discrepancy in the sum function. It might even suggest specific test cases or debugging techniques to help you isolate the problem further. By leveraging Copilot's code analysis capabilities, we can streamline the debugging process and quickly identify the root cause of the issue. This allows us to fix the error and ensure the accuracy of our sales calculations, leading to more reliable and trustworthy data insights. By combining the power of AI-powered error detection with traditional debugging techniques, we can create a robust and efficient workflow for identifying and resolving errors in our code. This not only saves time, but also leads to cleaner, more reliable code that performs as expected. Remember, debugging is an essential part of the software development process. By embracing AI-powered tools and mastering debugging techniques, you can become a more proficient and confident coder.
In the world of coding and data analysis, encountering unexpected errors or bugs is inevitable. These pesky glitches can disrupt your workflow, leaving you feeling frustrated and stuck.
Not another error. What's going on here?
Hey Sam, looks like you've hit a snag. Need a hand?
Yeah, I'm getting this weird error message, and I can't figure out what's causing it.
No worries, we've all been there. Debugging is just part of the coding journey. You just need the right debugging tools to help you along the way. Sometimes you can look into the details of the error messages that accompany errors to see if it indicates the file name and line number where the error occurred. But beyond that, there are several ways to examine what's going wrong. First up, we have breakpoints, your trusty checkpoints along the coding journey. By strategically placing these in your code, you can pause its execution at specific moments, allowing you to examine the values of variables and pinpoint the exact location of an error. Next, we have step-through execution, the ability to walk through your code one line at a time.
Like retracing your steps to find a lost item?
Yes, It helps you observe how each line of code affects your data and identify any unexpected behavior. This visual cue helps you track the program's progress as it moves through the code. And we have variable inspection, your window into the inner workings of your code. By examining the values stored in variables at different points in your program, you can uncover hidden clues and track down the source of those pesky errors.
Wow, thanks, Ria. These tools seem really helpful. I'm ready to tackle this bug head on. I found it. It was a little typo all along.
See, with the right tools and a bit of persistence, you can conquer any coding challenge.
Don't let bugs hold you back. Equip yourself with the right debugging tools and watch your coding confidence soar.
Let's take a look at a hands-on exploration of debugging tools and techniques through intelligence of AI. In this video, we'll go beyond identifying errors and witness how these tools can help you navigate through the complexities of code, determine the root causes of issues, and ultimately achieve a bug-free program. We'll look at the essential debugging features offered by modern code editors, demonstrating how they can speed up your debugging workflow and boost your productivity. By the end of this video, you'll be able to describe debugging techniques to troubleshoot and correct errors in generated code. Let's set the stage with a basic Python script that calculates the factorial of a number. However, we've intentionally introduced a subtle error that might not be immediately obvious. We'll use this script as our playground to demonstrate various debugging techniques. Let's start by running the script and observing its behavior. The script is not producing the expected result. It's time to use the power of our debugging tools to find the root cause of this issue. The first feature we'll look at its breakpoints. Breakpoints allow us to pause the execution of our code at specific lines, giving us a chance to examine the program's state and the values of variables at that particular point. We will select a specific spot in the code. We've set a breakpoint here, just before the recursive call. Now let's run the script in debug mode. The execution pauses at the breakpoint while the debugger highlights the current line. Now we can inspect the values of variables using the debugger's variable inspection feature. Open the debugging panel to see the values of the relevant variables at the breakpoint. By carefully examining these values, we can start to trace the flow of execution and identify any unexpected or incorrect values that might be causing the error. We will use the step over command in the debugger. We can also use the step into command to look deeper into function calls and explore their internal logic. This is particularly helpful when you suspect the error might be originating from within a function that your code is calling. By stepping into the function, the debugger will navigate to the function's definition and allow you to examine its code line by line, just as we did with the main script. You can then inspect variables within the function's scope and observe how they change as the function executes, helping you determine the exact location of the error. The debugger will also tell us the values of the function's parameters and local variables. Another powerful debugging technique is the use of watch expressions. We'll start by selecting the watch expressions in our debugger interface. To add a watch expression, simply type the name of the variable or the expression you want to track into the watch expressions panel. We will add in the factorial_result expression. The debugger will then continuously evaluate this expression and display its value as you step through the code. This real-time monitoring can be incredibly helpful in identifying unexpected changes or inconsistencies in variable values, which can often point you directly to the source of an error. By observing how these values change at each step of the execution, we can gain valuable insights into the program's behavior and identify any unexpected or incorrect calculations that might be contributing to the error. This view of your variables allows you to find the exact moment something goes awry, making it easier to trace the root cause of the problem. Now let's explore another powerful tool in our debugging features, the call stack. The call stack provides a historical record of the function calls that led to the current point of execution. When we open the call stack panel in the debugger, it will display a list of function calls to select from. By examining the call stack, we can see the sequence of functions that were called, their arguments, and the line numbers where they were invoked. This can be particularly helpful when dealing with recursive functions or complex program structures. If an error occurs, the call stack will highlight the exact function and line of code where the problem originated. You can then navigate to that specific location in your code and examine the logic or variable values to identify the root cause of the error. By combining the power of traditional debugging tools with the intelligence of AI, we can create a more efficient and effective debugging workflow. This empowers us to identify and resolve errors faster, write cleaner code, and ultimately build more reliable and robust applications.
Let's explore how to understand confusing error messages and find the source of the problems in your code. By the end of this video, you will be able to describe strategies for debugging AI-generated code, including tips for interpreting error messages and effectively narrowing down the source of problems. Debugging AI-generated code can be challenging and involve unexpected difficulties. But don't worry, with the right strategies and some patience, you can handle any code problems you encounter. Your first step should be to acknowledge that AI models, while powerful, can make mistakes. They learn patterns from vast amounts of data, but they don't possess the same contextual understanding or logical reasoning abilities as a human programmer. As a result, the code they generate may be syntactically correct, but logically flawed, leading to unexpected errors. To debug effectively, you need to understand the assumptions it made, the patterns it recognized, and the limitations it may have encountered. This will help you anticipate potential problem areas and narrow down your search for errors. Error messages can help you find and fix problems in your code, but they can sometimes be confusing or misleading. Don't be discouraged if you don't understand them immediately. Take your time to analyze the message, break it down into its components, and try to relate it back to the specific line or section of code where the error occurred. Pay close attention to keywords in the error message, such as syntax error, type mismatch, or index out of bounds. These provide clues about the nature of the problem and can guide you toward a solution. Once you have a general idea of the error, it's time to start narrowing down its source. There are a few strategies you can use. The first is to isolate the problematic code. Try to identify the smallest possible section of code that triggers the error. You can do this by commenting out different parts of the code or by using debugging tools to step through the code line by line. Then, check your inputs. AI models are highly sensitive to the data they receive. Make sure the input data you're providing is in the correct format, has the expected values, and doesn't contain any missing or corrupted data. Also, review the model's assumptions. As mentioned earlier, AI models make the assumptions based on the data they've been trained on. These assumptions may not always hold true in your specific use case. Review the model's documentation or training data to understand its limitations and potential biases. Finally, use print statements or logging. Insert print statements or logging functions at strategic points in your code to track the flow of data and identify where things might be going wrong. You can often use generative AI itself to help you debug AI-generated code. There are a few ways to do this. If you're struggling to understand a particular section of code, you can ask the AI model to generate an explanation in plain language. This can help you uncover hidden assumptions or logic errors. And if you suspect a particular section of code is causing the problem, you can ask the AI to generate alternative implementations. This can help you identify potential fixes or workarounds. Also, there are a growing number of AI-powered debugging tools that can automatically analyze your code, identify potential errors, and even suggest fixes. Remember that patience is key. Debugging can be a challenging process, so don't get discouraged if solutions don't come easily. Take breaks, approach the problem with a fresh perspective, and persist until you uncover the root cause. It's also important to maintain a methodical approach by documenting errors, steps taken, and outcomes. Don't hesitate to collaborate with colleagues or seek help online. A peer can often provide valuable insights. Finally, view every debugging experience as a learning opportunity. Analyze the errors you encounter and the strategies you employ to become a more proficient and effective debugger over time. As you gain more experience with debugging AI-generated code, you may want to explore some more advanced techniques. write unit tests to verify the correctness of individual functions or modules in your code. This can help you catch errors early in the development process and prevent them from cascading into larger problems. Test how different parts of your code interact with each other. This can help you identify compatibility issues or unexpected side effects. Use profiling tools to measure the performance of your code and identify bottlenecks or areas for optimization. Have another developer review your code to identify potential errors or areas for improvement. Debugging AI-generated code might initially feel challenging, but with appropriate strategies and persistence, you can overcome any obstacle. Remember to consider the AI's approach, carefully examine error messages, and systematically identify the cause of issues. By using the capabilities of generative AI and employing effective debugging techniques, you'll be well on your way to becoming proficient in debugging AI-generated code. When you're working with AI-generated code, the performance of the model depends on several factors. By the end of this video, you will be able to describe the key factors that influence the performance of AI-generated code, such as model choice, prompt quality, and input data. You'll first need to think about model choice. Large language models, like the one generating your code, are trained on vast data sets and can handle a wide variety of coding languages, but each model has strengths and weaknesses depending on its training data. Some models are better at working with complex algorithms, while others might be better at generating basic code for standard functions. Knowing which model you're using helps you set realistic expectations for the kind of code it can generate. For example, if you're working on generating code for a simple task like automating a repetitive function in Python, a smaller, faster model may be enough. However, if you're dealing with complex, multi-step algorithms that require deep knowledge of libraries or frameworks, a more powerful specialized model may perform better. Some models might also have specific training on certain industries. So if your work involves fields like financial data analysis or medical data analysis, picking a model trained in those areas will lead to more precise results. The model choice essentially sets the boundaries for the kind of code you can expect, and understanding the scope of your chosen model allows you to anticipate the kinds of adjustments you'll need to make to the generated code. Next, you need to focus on prompt quality. The prompt is what you feed into the AI to instruct it on what kind of code to generate. Even though the AI might seem capable of understanding context, it relies entirely on the clarity and structure of your prompt to produce accurate results. Your prompt should be specific and focused to get the best output. If your prompt is vague or open-ended, the model might not generate the exact code you need, or it could include unnecessary elements that you'll have to clean up later. For instance, instead of typing, "generate a Python function," you might say, "generate a Python function that calculates the average of a list of numbers, handles empty lists, and returns 0 in such cases." The second prompt provides a detailed set of instructions, which increases the likelihood of receiving the exact output you're looking for. Additionally, if your task involves multiple steps, break those down clearly within the prompt. If you expect the AI to combine several operations into one function without guidance, it may misinterpret the order or importance of the steps. Your input data also plays a key role in the performance of the AI-generated code. The more relevant and high quality the input data, the better the output. Think about the structure and complexity of the data you're using. If the model receives inconsistent or incomplete data, the generated code might not perform as expected. You should aim to format the input data in a way that the AI can understand easily. For example, if you're working with datasets that have missing values or anomalies, ensure that the input reflects this. You may want the model to include error handling code that accounts for these gaps. One common challenge you'll deal with is adjusting the input data to make it compatible with the generated code. AI models don't have perfect foresight, and they can't predict every edge case or exception your real-world data might present. By cleaning and formatting your input data before feeding it into the model, you can minimize the likelihood of errors when the AI generates the code. For example, if you're generating code to analyze customer transactions, ensure the input data has consistent field names and data types, and that any edge cases, like null values or outliers, are noted in the prompt. When all of these elements, model choice, prompt quality, and input data, come together effectively, the AI-generated code becomes far more reliable. However, it's important to recognize that the code the AI produces is rarely perfect on the first try. You'll need to review the output and make manual adjustments. Sometimes the model misinterprets complex prompts or makes assumptions that don't fit your specific needs, and the code might lack optimization or clarity in certain areas. For instance, even with the best prompts, AI may not account for performance optimization unless explicitly asked. If you're generating code for a high-traffic website that needs efficient algorithms to handle large volumes of data quickly, you may need to tweak the AI's output to meet those performance requirements. Likewise, some code might not be written in the most readable format, especially for larger projects. You may need to refactor the AI-generated code to align with coding standards or conventions used by your team. Remember, AI-generated code performance is driven by the model choice, the prompt quality, and the input data. By carefully considering these factors and making adjustments as needed, you can significantly improve the reliability and accuracy of the code generated. When you're working with AI code generation models, it's not just about providing a prompt and getting code back. The real power comes from exploring the settings these models offer. By the end of this video, you will be able to explain the advanced settings and configurations available in various AI code generation models. You'll also be able to describe how tweaking parameters, using custom libraries, and fine-tuning prompts can significantly improve code efficiency and tailor the output to specific needs. Let's start with tweaking the model parameters. Every model has a range of settings that allow you to control its behavior. For example, one of the key parameters you'll encounter is temperature. This setting controls how creative or random the model's output is. A lower temperature, that is closer to 0, will generate more predictable, conservative code based on the data it was trained on. And a higher temperature will introduce more variability, allowing the AI to generate creative, unconventional solutions. You'll want to adjust the temperature based on the task at hand. If you're looking for a standard implementation of a well-known algorithm, like sorting or searching, a lower temperature will give you reliable conventional code. But if you're working on something more experimental or you need innovative approaches, increasing the temperature might lead to more interesting results. Another parameter you can control is max tokens. This limits the length of the code the model generates. If you need quick, concise functions, you might set a lower token limit to avoid unnecessary lines of code. Keep in mind that a higher max token setting can sometimes lead to more verbose code, so you might have to refine it later. Now, consider the use of custom libraries. Generative AI models can be guided to generate more efficient or tailored code by prompting them to integrate specific libraries. This can be especially useful when you're working within particular constraints, like optimizing for performance or following industry standards. If you specify a library in the prompt, like NumPy for numerical operations or Pandas for data manipulation, the AI will structure its code around the best practices associated with that library. You can even introduce your own custom libraries or APIs into the prompt. If you're working with proprietary tools or specific frameworks, you can guide the AI to incorporate those elements into the generated code. For example, if your company uses a custom-built machine learning library, you can instruct the AI to include that in its output. Speaking of prompts, prompt engineering is a critical factor when working with AI-generated code. Your prompt needs to be precise and detailed. It's not enough to simply say, "Generate a Python function." You need to guide the AI step by step, ensuring that the generated code meets your exact requirements. For instance, you can specify the input and output formats, the expected performance constraints, or any error handling you want the code to include. Let's say you want the AI to generate a function that processes customer data and flags any anomalies. Instead of asking for a function that detects anomalies, you should describe the conditions under which you consider something an anomaly. You might say, generate a Python function that takes in a Pandas data frame, checks for transactions greater than $10,000 or more than 3 standard deviations away from the mean, and returns a list of flagged entries. This level of specificity ensures that the AI generates code that directly solves your problem without unnecessary adjustments. As you work on more advanced tasks, you can also fine-tune the model itself. Some AI models allow for additional training on your specific datasets or problems. This can be useful if you're working in a niche field where general-purpose models may not have been trained on the data relevant to your task. For example, if you're in the financial sector and need AI-generated code that deals with compliance reporting, fine-tuning the model with examples of code that's already optimized for compliance tasks can result in much more relevant and usable output. While fine-tuning the model helps tailor its understanding to your domain, you'll still need to review the generated code for optimization. AI models can generate functional code, but they may not always produce the most efficient or elegant solutions. You'll want to take the time to review and refactor the code, especially if performance is a key consideration. In some cases, AI-generated code might solve the problem, but with redundant loops or overly complex logic that could slow down execution in large-scale systems. In the end, generating efficient and relevant code using AI is about understanding the tools and parameters available to you. By adjusting model settings, integrating custom libraries, and refining your prompts, you can tailor the output to your specific needs. Combine this with careful review and optimization, and you'll be able to generate code that doesn't just work but works well for your unique context.
You know, Rowan, for all the buzz about AI coding, I still believe there's no substitute for good old-fashioned manual coding skills.
I hear you, Ria, but I think AI coding is revolutionizing the way we work. It's like having a superpower that amplifies our abilities.
Superpower, huh? Don't get me wrong, AI can be helpful, but it's no replacement for the deep understanding and control you get from hand coding.
I see your point, but AI coding isn't about replacing us. It's about empowering us. It frees us from tedious, repetitive tasks so we can spend more time building, creating, and refining our code to achieve its full potential.
I worry that relying too much on AI can make us complacent. We might lose touch with the fundamentals and become dependent on a black box we don't fully understand.
That's a valid concern, Ria, but I see AI as a tool, not a crutch. It's about collaboration, not replacement.
How do you envision that collaboration working? How can we leverage AI's capabilities while still honing our own coding skills?
Well, for starters, AI can help us generate code snippets quickly, freeing up time for us to focus on more creative and strategic aspects of data analysis. We can also use AI to test and debug our code, ensuring its accuracy and efficiency.
And now we're back to troubleshooting the code AI generates to check the code AI generates. So we're essentially using AI to fix the problems AI creates? Sounds like a never-ending loop.
Fair point, Ria. But remember, AI is still a tool in our hands. We can use it to augment our skills, not replace them. By working alongside AI, we can achieve more than we ever could alone.
I guess we'll have to see how it all plays out, but I'll always champion the importance of learning the fundamentals.
It's about finding the right balance. I'll keep pushing the boundaries of what's possible with AI, but I know I need to keep my critical thinking skills sharp.
Whether we embrace AI as a tool or rely on our manual skills, the key is to remain adaptable, curious, and always striving to unlock the full potential of our data.
Welcome back. In this video, we'll go beyond traditional coding practices and witness how AI, specifically tools like Copilot, can significantly accelerate development, handle large volumes of data more efficiently, and assist with complex tasks. We'll look at real-world examples of how generative AI is being used to speed up workflows, boost productivity, and allow developers to achieve more in less time. By the end of this video, you'll be able to evaluate the advantages and limitations of using generative AI for complex coding tasks compared to manual coding. Let's begin by addressing a common challenge in software development: repetitive and time-consuming coding tasks. Whether it's writing boilerplate code, generating test cases, or refactoring existing code, these tasks can often slow down development and hinder productivity. This is where generative AI, like Copilot, steps in to automate and accelerate these tasks. Let's explore how Copilot's generative AI capabilities can turbocharge your coding efficiency. As you start typing code, you'll notice that Copilot begins suggesting completions in real time, predicting variable names, function calls, or even entire code blocks based on the context of your code and your intentions. We can start typing in def calculate underscore sum underscore loop parentheses numbers colon. These suggestions aren't just random guesses. They're rooted in patterns and best practices taken from an extensive analysis of millions of lines of code. This intelligent assistance not only accelerates your coding process, but also significantly reduces the likelihood of errors, leading to cleaner and more reliable code. Let's go ahead and accept one of these suggestions and integrate it into our code. Copilot's capabilities go beyond simple completions. Let's say you want to create a function to filter a list of data based on certain criteria. Instead of writing the code from scratch, you can simply describe your intent in a comment. We can type a comment like #filter the list to keep only even numbers. Now watch as Copilot generates the corresponding Python code snippet right below your comment. Copilot generated filtered underscore numbers equals bracket num for num in numbers if num%2 equals 0 bracket, accurately implementing the filtering logic based on the natural language description. This is an example of how Copilot can understand your intent and translate it into functional code, saving you valuable time and mental effort. You can even ask Copilot to generate entire classes or modules based on high-level descriptions or requirements. Let's type in #create a class to represent a customer with attributes for name, email, and purchase history. This level of automation not only accelerates development, but also reduces the cognitive load on developers. This allows them to focus on the bigger picture and the core logic of their applications. The time saved by using Copilot can be substantial, especially for repetitive or boilerplate code. This allows developers to iterate faster, experiment with new ideas, and ultimately deliver higher quality software in less time. Next, let's explore how generative AI can empower developers to handle large volumes of data more efficiently. Imagine you're working with a massive dataset containing millions of rows and hundreds of columns. Manually writing code to clean, transform, and analyze this data can be a daunting task. This is where Copilot's ability to understand the context of your data and generate relevant code snippets becomes invaluable. Copilot can help you navigate this complexity by suggesting relevant code snippets, data transformations, and even visualization options based on your intent and the context of your analysis. This AI-powered assistance not only speeds up the analysis process, but also helps you discover insights that might have been missed with manual exploration. Finally, let's tackle complex coding tasks that were once considered the domain of experienced developers. Let's look at a challenge such as implementing a machine learning algorithm. Generative AI can assist in these scenarios by generating code skeletons. Let's see how Copilot can streamline the initial setup. We can start typing #create a class to train a random forest classifier to predict the quantity column. Copilot can recognize this intent and provide you with a basic code structure, including the variable declarations and even placeholders for key steps in the algorithm's implementation. Through combining the power of AI with your own expertise and judgment, you can achieve an effective balance that unlocks new levels of productivity, creativity, and innovation in your coding endeavors. This will ultimately allow you to build better software faster and with greater confidence.
When you're working with generative AI for coding, it's important to understand where it excels and where human expertise is needed. In many situations, AI can save you time by generating functional code quickly. But there are also cases where AI's limitations mean that you, as a human analyst, will need to step in to refine or rewrite the code. By the end of this video, you will be able to describe practical coding scenarios where generative AI excels, as well as situations where human expertise is crucial, providing a balanced view of AI's role in data analysis coding. Let's start with a situation where generative AI excels, creating repetitive or standard code. Suppose you're working on a data analysis project and you need to write functions to clean data, removing null values, standardizing text formats, or converting date fields. These tasks are straightforward but time-consuming if you write each function manually. Here, AI can help you generate basic functions quickly. You might prompt the AI with something like, write a Python function to remove null values from a pandas data frame, and it will give you working code almost instantly. This kind of task doesn't require complex logic or deep understanding, making it ideal for AI. You get a functional piece of code in seconds that you can immediately use or adapt. Now, let's look at another case where AI performs well: generating standard algorithms. If you need to implement a common algorithm like sorting data, calculating averages, or even more advanced tasks like creating a linear regression model, AI can handle this with ease. You can provide the AI with a prompt such as, generate Python code to implement a linear regression model using scikit-learn, and it will generate working code that imports the correct libraries, sets up the model, and fits the data. This is extremely helpful, especially when you need to produce code quickly and don't want to spend time recalling exact syntax. Let's shift focus for a moment to where human expertise is essential. Imagine you're dealing with a complex data set and need to implement a custom algorithm that doesn't follow standard patterns. Maybe you're analyzing customer behavior and want to identify a specific trend that requires combining several models, like clustering algorithms followed by predictive analytics. AI can attempt to generate code, but it might not fully understand the nuances of your specific business logic or goals. In this scenario, AI can give you a basic framework, but you'll need to bring in your knowledge of the data and how those models should interact. Your deep understanding of the data, business context, and desired outcome will be essential in guiding the AI to generate the right solution. While AI can provide a good starting point, it won't necessarily understand the subtle decisions required to make that code truly effective. For example, AI might miss how to handle edge cases or nuances in your data that require custom logic. This is where your expertise and intuition come into play, refining the AI's output to ensure the code solves your specific problem. Now, consider a situation where you're integrating several APIs into a large data processing pipeline. This is a more complex task, where AI can generate basic code to call and extract data from APIs. For example, you can ask the AI to generate code that connects to a weather API and retrieves temperature data. But once you start integrating multiple APIs, handling authentication, managing asynchronous requests, and ensuring the data flows correctly between different parts of your system, things get more complicated. AI can still help by giving you the foundation, such as generating the individual API calls or setting up the basic framework for managing data. However, this type of work often requires a deeper understanding of how systems interact with one another, how to handle errors effectively, and how to optimize the performance of the code to ensure it scales properly. AI might not fully understand how to structure these integrations for your specific needs, leaving gaps in error handling or performance optimizations that only you can address. To sum it up, generative AI for coding is an incredible tool that can boost productivity and handle repetitive or standard tasks with ease. In scenarios where you're working with common algorithms, repetitive functions, or API calls, AI can provide a solid foundation. It helps you generate code quickly, saving you time on routine coding tasks. But when it comes to complex custom logic, system integrations, and performance optimization, your expertise is key. AI can give you a starting point, but it's your understanding of the data, the business problem, and the coding environment that will lead to a solution that works well. In these cases, the AI-generated code becomes more like a draft, and it's up to you to refine and optimize it.
In data analysis, the allure of AI-generated code is undeniable. It promises speed, efficiency, and the ability to tackle complex tasks with ease. Hey Sam, how's that project coming along? I see you're trying out the new AI coding assistant.
Yeah, I'm giving it a shot, but I'm still not entirely convinced.
I know it can be a bit intimidating at first, but it's incredibly fast and efficient. I've been able to tackle complex calculations that used to take me hours in just a fraction of the time.
Really? That sounds impressive, but can I really trust the AI to generate code that's correct and reliable?
Absolutely. The AI has been trained on tons of data and code, so it's usually spot on with its suggestions. But checking the code for errors and validating that it's exactly what you want is part of the process.
Okay, I'll give it a try. This is amazing. I'm getting so much more done in less time. Wait, that's not right. Why is the AI generating this code? It doesn't make sense in this context.
Hmm, that's strange. Let me take a look. Sometimes the AI's suggestions need a little tweaking. It can sometimes produce code that is inaccurate or inefficient when dealing with complex or nuanced data. We can probably adjust a few parameters or add some additional logic to get it working just right.
You know, Rowan, as much as I'm enjoying the efficiency of AI coding, I'm starting to wonder about its limitations. Like, what if the AI generates code that's misleading or inaccurate?
I have heard stories about AI models producing biased results or making inaccurate predictions, especially when the training data is flawed or incomplete.
Exactly. And what if it introduces security vulnerabilities into our systems? We deal with sensitive customer data.
Those are valid concerns, Sam. AI is a powerful tool, but it's not infallible. We need to maintain a critical eye, carefully review and test the code, and ensure it aligns with our ethical and regulatory standards. So, embrace the power of AI coding, but remember to wield it responsibly. AI is a powerful tool, but it's your critical thinking and expertise that truly unlock its potential.
Have you ever wished you had a coding companion to help you navigate the complexities of data analysis? Meet Erwin. Erwin is a dedicated data analyst with a passion for uncovering insights. But lately, the coding side of the job has been feeling overwhelming. Tight deadlines, endless bug fixes, and the constant pressure to learn new programming languages have left Erwin feeling exhausted. But what if Erwin could find a tool that could help him code faster, smarter, and with more confidence? Enter the Code Whisperer, an AI-powered coding assistant that just might be a data analyst's new best friend. It's not a dream. An AI coding assistant uses generative AI to suggest code snippets, complete functions, and even catch errors before they happen. Erwin gets back to work. The AI-powered coding assistant acts as an intelligent coding partner, anticipating Erwin's needs and offering suggestions and completions in real time as he types. Erwin can easily accept or reject these suggestions with a simple keystroke or mouse click. But the AI coding assistant's capabilities go beyond just suggestions and auto-completions. Erwin can express his coding intentions in plain language, and the AI assistant translates them into functional code snippets. Say he wants to look only at a particular aspect of the data. Erwin can just type, "Show me the sales from last quarter." Then the AI assistant will generate code to filter the dataset. This ability to understand plain language streamlines Erwin's workflow significantly, allowing him to focus on the logic and purpose of his code rather than getting bogged down in syntax and implementation details. No more late nights spent debugging. No more feeling overwhelmed by complex coding tasks. Just Erwin, his data, and the insights he's passionate about uncovering. The AI coding assistant has transformed Erwin's work, freeing up time for more strategic tasks and allowing him to focus on what truly matters, contributing to data-driven decisions that drive his business forward. So, if you're a data analyst feeling the coding crunch, remember you're not alone. Embrace the power of generative AI and let the Code Whisperer become your new best friend.
Welcome to an exploration of code generation with generative AI. In this video, we'll go beyond the traditional methods of coding and witness how AI is changing the way we write, optimize, and even debug code. We'll display how AI-powered tools can generate code snippets, complete functions, and even entire programs, all based on natural language descriptions or prompts. By the end of this video, you'll be able to define code generation and identify common use cases for generative AI in data analysis. Traditionally, writing code required extensive knowledge of programming languages, syntax, and algorithms. But with the advancements in generative AI, we can now leverage the power of natural language to create code, making programming more accessible and efficient. We can take a look at hands-on demonstration of AI-powered code generation. Let's say you need to write a Python function to calculate the average of a list of numbers. Instead of manually crafting the code, you can leverage the power of Copilot's code generation capabilities. Open up Copilot. Simply type your request in the chat input field using clear and concise language. For our example, we'll ask, write a Python function to calculate the average of a list of numbers. Copilot will process your natural language description and generate the corresponding Python code snippet, complete with the necessary logic and syntax. Copilot provides a functional and well-structured code snippet in response to your natural language prompt. This is just a glimpse of its code generation power. You can request more complex code, optimizations, or even entire programs. Now let's shift gears and explore how Copilot can assist with generating code for other languages, such as SQL. This versatility empowers you to interact with different data sources and perform a wider range of analysis tasks. Imagine you need to retrieve the top 10 customers by total sales from a database. Before AI, you'd have to write an SQL query, carefully crafting the select, from, where, group by, order by, and limit clauses. But with Copilot, you can simply describe your desired outcome in plain English. Let's ask it to generate an SQL query to retrieve the top 10 customers by total sales. Copilot will process your request and generate a syntactically correct SQL query that fulfills your requirements. You can then copy this query, paste it into your database management tool, and execute it to get the desired results. This saves you time and effort, especially if you're not intimately familiar with SQL syntax or complex query structures. This seamless code generation capability empowers you to interact with various data sources and perform diverse analysis tasks, even if you're not a coding expert. Let's shift our focus to how code generation can specifically enhance data analysis tasks. Imagine you have a dataset and want to visualize the distribution of a particular variable. Instead of manually writing the code to create a visualization, describe your goal to Copilot. Let's type in, write a code to visualize the distribution of the age column from a data frame in a histogram using matplotlib. Copilot understands your intent and generates the corresponding Python code, including necessary imports and plotting commands. With this generated code, you have a visualization ready for analysis, streamlining your workflow. We can see a histogram that depicts the distribution of the age variable. Now, let's explore how Copilot can help us optimize our code for better performance and efficiency. Let's say we have a Python function that performs some calculations, but it's running a bit slow. We can ask Copilot to suggest ways to optimize it. We can type in the prompt, optimize this Python function for performance. Copilot will analyze the code and provide suggestions for improvement. These might include using more efficient algorithms, leveraging built-in libraries, or optimizing specific code blocks. By implementing these suggestions, we can often achieve significant performance gains, making our code run faster and smoother. Finally, let's see how Copilot can assist us in the often frustrating process of debugging. Let's say we have a piece of code that's throwing an error, and we're having trouble figuring out the cause. We can say, help me debug this Python code. Copilot will analyze the code, identify potential issues, and provide explanations and suggestions for fixing the error. Copilot's ability to understand code context and provide targeted debugging assistance makes it a valuable companion for developers of all skill levels. Generative AI is revolutionizing how we interact with code. It automates tasks, boosts productivity, and makes coding more accessible. Embrace this technology to unlock new levels of efficiency and creativity in your data analysis, allowing you to focus on the insights that drive success.
Learning to use AI for code generation in data analysis opens up exciting possibilities. By the end of this video, you'll be able to describe how to use AI in tasks like cleaning, exploring, and visualizing data. Let's talk about how you can use these tools to make your work more efficient, starting with data cleaning. When you start cleaning a dataset, the first thing you'll probably need to address is missing or inconsistent data. This is where AI-generated code helps. Instead of writing every line of code manually to handle missing values or standardize inconsistent entries, you can prompt your AI tool to generate code for these tasks. For instance, you could input a prompt like, "Write Python code to fill missing values in the numerical columns of this dataset using the mean of each column." And the AI will generate the appropriate script for you. As you go through your dataset, you may encounter errors that are more complex, like mismatched data types or outliers. In these cases, you can use AI-generated code to not only identify the issues, but also fix them. You might say, generate code to detect outliers in this column using the interquartile range, or IQR, method. The AI will respond with the code you need to highlight the problematic rows, saving you the time of looking up specific syntax or writing complex logic manually. Moving on to data exploration. This step involves exploring your dataset to understand its structure and gain initial insights. You'll want to run some basic exploratory analysis, and instead of manually writing a series of commands to generate descriptive statistics or visualizations, you can prompt your AI tool for help. For example, you could ask, "Generate Python code to give me summary statistics for the numerical fields of these datasets. Make the statistics their own data frame and return it. Then, for each string column, print the value counts of these fields." The AI should output code that shows the mean, median, standard deviation, and other key statistics, as well as important information on additional string fields, saving you time and effort. Once you've explored your data, it's time to think about visualizing it more thoroughly. You may be familiar with visualization libraries like Matplotlib, but typing out every plot manually takes time, particularly when you need to create more than one visualization. Let's say you want to generate several graphs showing different aspects of your dataset. You can ask the AI, "Generate Python code to create histograms for each numeric column in this dataset." And it may, for instance, respond with a script that loops through the columns and outputs histograms for all of them in one go. Let's talk about a situation where you're trying to automate some of these tasks. You can use generative AI to create reusable scripts that automate repetitive steps in your workflow. Imagine you frequently clean and explore datasets with similar issues, missing values, outliers, and a need for initial visualizations. You could ask the AI to generate a script that automatically performs these actions for any datasets you input. For example, generate a Python script that fills missing values, detects outliers, and provides summary statistics for any CSV file. Make a function that has input of a CSV file and outputs of the clean datasets, the summary statistic, and a new dataset of just the outliers across all fields. This script can then be reused whenever you encounter similar datasets, making your entire process more efficient. Now, consider a more complex scenario, such as working with machine learning models to predict future outcomes based on your cleaned and explored data. You can ask the AI to assist you in generating the code for this step too. Say you're dealing with a regression problem, and you want to train a model. Instead of manually coding each step, you can ask the AI to generate all the necessary code. A simple prompt like, "Generate code to train a linear regression model using this dataset and evaluate its performance using RMSE," will give you a complete script. You should have everything from the train test split to performance metrics in a matter of seconds. This is a more advanced task, so don't be discouraged if the code does not run perfectly on the first try. Remember, working with AI is an iterative process, and adjustments may be necessary to get exactly what you're looking for. One advantage of using AI-generated code is that it not only speeds up these processes dramatically, but also ensures fewer syntax errors. Since these models are trained on functioning code and documentation, it's less prone to human error like typos or incorrect logic. This means you can rely on your AI to write accurate scripts, which helps when you're working under tight deadlines or in large projects where mistakes can slow you down. To get the most out of this approach, it's important to engage with the generated code. You're not just passively copying and pasting. The AI generates the base, but you can tweak the code to suit the specific needs of your analysis. By understanding what the code does and why, you'll be able to make quick adjustments if something needs fine-tuning, whether it's the threshold for detecting outliers or the type of visualization you're creating. In the end, using generative AI for code generation in tasks like cleaning, exploring, and visualizing data can significantly streamline your workflow. It allows you to focus more on interpreting the results and less on the manual coding that usually accompanies these steps. Let's describe what a typical workday can be like for data analysts who use code generation tools. By the end of this video, you'll be able to describe how to use code generation tools to tackle various tasks, discuss how to incorporate AI into a workflow from initial data exploration to final report generation, and you'll be able to explain how code generation can transform the daily experience of a data professional. Imagine this. You arrive at work, get your coffee, and start your computer. Your inbox is already full, but don't worry, AI can help. Your first task is to analyze customer churn data. Instead of manually writing SQL queries, you use a code generation tool. You describe what you need by writing, "Write me a SQL query to show the top 10 reasons for customer churn and their counts in Q3 of 2024 from the churn surveys table." The tool gives you a perfectly crafted SQL query, saving you precious time. Next, you need to visualize this data. You could spend hours working with charting libraries, or you tell your AI assistant, use Python to create a bar chart showing churn reasons and their frequency. The data frame name is churn responses, and the field is explanation. And then the code for a beautiful visualization appears. As you further explore the data, you notice some interesting patterns. You want to understand the factors that influence churn. This is where AI's predictive power helps. You feed your data into an AI-powered analytics tool, and it identifies the key predictors of churn. You now have actionable insights to present to the marketing team. But your work isn't done yet. You need to communicate your findings clearly. You could spend hours writing a report, but why not let AI help? You feed it your analysis and some instructions about how and what to communicate with your specific audience, and it generates a draft report, complete with visualizations and key takeaways. You refine and polish it, and your report is ready to impress. Now, let's see how this all fits into your daily workflow. AI-powered tools for data exploration can help you quickly understand your data's structure, identify anomalies, calculate key statistical metrics, and suggest relevant visualizations. For data cleaning and preparation, AI tools can automate mundane tasks like handling missing values, formatting data, and detecting outliers. When it comes to analysis, code generation tools save you time by writing complex queries, while AI-powered coding environments and code interpreter tools uncover hidden patterns and insights. For visualization, AI assistants write code to generate charts and graphs on demand, making your data more accessible and understandable. Some visualization platforms are implementing AI functionality as well. Finally, AI supports reporting by helping you create clear, concise reports that effectively communicate your findings. Imagine this. You're working on a tight deadline. You need to analyze a very large dataset and present your findings by the end of the day. Previously, this would have been a very difficult task, but with code generation and AI, you generate queries in seconds, visualize your data effortlessly, and let AI help you create a compelling report. You meet your deadline and impress your boss. Let's talk about some specific ways you can integrate code generation tools into your workflow. Think of them as your coding assistants, ready to help whenever you need them. When it comes to data cleaning, instead of manually writing code to tackle missing values or format data, simply articulate your needs to your code generation tool, and it will generate the code for you. Need to pivot a table or aggregate data for transformation? Your AI assistant can help. For exploratory data analysis, EDA, leverage code generation to quickly produce summary statistics, histograms, or scatter plots, gaining a deeper understanding of your data's distribution and identifying potential trends. Machine learning engineering tasks like feature engineering can be streamlined with code generation tools. This allows you to automate the process and experiment with various features to enhance your model's performance. The key is to experiment and find what works best for you. Don't be afraid to try new things and push the boundaries of what's possible. With code generation and AI, the possibilities are endless. Now, you might be thinking, this all sounds great, but what if I don't have any coding experience? No worries. Many code generation tools are designed to be user-friendly even for those without a technical background. You can describe what you need in plain English, and the tool will translate it into code. But even if you are comfortable with coding, these tools can still be a huge time saver. They can help you avoid syntax errors, generate boilerplate code, and even suggest optimizations. It's like having additional support, allowing you to focus on the more creative and strategic parts of your work. So there you have it, a look at how code generation and AI are transforming the daily experience of data professionals. It's an exciting time to be in this field, and these tools are just the beginning. As AI continues to evolve, we can expect even more powerful and intuitive tools that will further enhance our productivity and creativity.
Erwin was thrilled with the AI code assistant, but he soon realized that he didn't always get the exact code he needed. Sometimes the AI's suggestions were slightly off, or it didn't quite grasp the nuances of his complex tasks. The key to unlocking the full potential of the AI assistant lies in careful prompt engineering. First, Erwin learns to specify the context of his request, including the programming language he'll use, the libraries he needs, and the structure of his data. This helps the AI assistant understand the environment and generate more relevant code. Today, Erwin starts with a prompt for the AI assistant to generate code to calculate the average customer purchase amount. But the code snippet the AI generates is calculating the total purchase amount instead. This doesn't align with Erwin's requirements. When Erwin used the word average, the AI assistant generated code to calculate the overall average of all customer transactions, including incomplete ones or returns. This highlights a key principle in prompt engineering: specificity and clarity. Next, Erwin provides more specific instructions. Generate code to calculate the average customer purchase amount, considering only completed transactions and excluding any returns. But even with the clearer prompt, Erwin received code that wasn't quite right. So Erwin refines his prompt structure, organizing it with clear instructions and breaking down complex tasks into smaller steps. By specifying the input, steps for processing, and the format of the output, he makes it easier for the AI assistant to generate well-structured code that aligns with his intentions. Erwin even includes examples of successful prompts he has used in the past, with varying levels of detail and specificity. This further guides the AI assistant and improves the accuracy of the generated code. With each refined prompt, Erwin gains more control over the AI's output. By crafting precise and detailed prompts, Erwin guides the AI to generate the exact code he needs, saving time and avoiding frustration. Together, Erwin and his AI assistant are ready to tackle complex data analysis tasks with ease and precision.
Welcome to an exploration of prompt engineering, the key to unlocking the full potential of generative AI models. In this video, we'll go beyond basic interactions with AI and learn the essential principles for crafting clear, concise, and specific prompts that create accurate and relevant responses. We'll discover how to modify your prompts to various tasks and domains, ensuring that you get the most out of your interactions with AI. By the end of this video, you'll be able to explain how to write prompts for generative AI models to produce SQL, Python, and R code snippets. When interacting with generative AI models, your prompts connect your intentions and the AI's capabilities. The clearer and more specific your prompts are, the more likely you are to receive accurate and relevant responses. Let's start by exploring the fundamental principles of prompt engineering. The first principle is clarity. Your prompt should be crystal clear, leaving no room for ambiguity or misinterpretation. If your prompt is vague, like, "Tell me about AI," AI will generate a response that's either too general or off-topic. When your prompts are vague or open-ended, the AI might struggle to understand your intent and could produce outputs that are irrelevant or unhelpful. Let's modify the prompt to be more clear. Avoid using jargon or technical terms that the AI might not be familiar with. Instead of "Tell me about AI," we can type in, "Explain the difference between artificial intelligence and machine learning in simple terms." Now let's explore the second principle of prompt engineering, conciseness. Just as a well-crafted sentence conveys its message efficiently, a concise prompt helps the AI model focus on the core task without getting lost in unnecessary details. This prompt is long and unclear. It contains extraneous information we don't need to include in the prompt. When prompts are excessively long or convoluted, they can overwhelm the AI and lead to less accurate or less relevant responses. Let's remove any unnecessary words or information. We can shorten it to the following. Provide a timeline of key milestones in AI history, including pioneers and breakthroughs. The third and final principle of prompt engineering is specificity. While AI models are capable of impressive feats of language generation, they thrive on clear direction. AI requires a specific prompt to deliver the desired output. If we type in, "Write something creative," we're going to receive an unfocused and generic response. A vague or open-ended prompt leaves too much room for interpretation, leading to unpredictable and potentially irrelevant responses. To get the most out of generative AI, it's essential to clearly define the task you want it to perform, the desired format of the output, and any relevant context or constraints. We can make our prompt more specific by typing in, "Write a haiku about the joy of learning." By providing this level of specificity, you guide the AI's creative process and increase the likelihood of receiving a response that aligns with your expectations. Now, let's see how to apply these principles to generate code snippets in different programming languages. Let's start with SQL. Imagine you need to retrieve data from a database table called customers, where the city column equals New York. We can simply prompt the AI with this request. Let's type in SQL query to select all columns from the customers table where the city is New York. The AI will utilize the prompt to then generate the corresponding SQL query. Next, let's try generating Python code. Let's say we want to create a function that calculates the factorial of a number. Type in, "Write a Python function to calculate the factorial of a number." The AI will process this prompt and generate the Python code. Finally, let's explore generating R code. Suppose we want to create a scatter plot to visualize the relationship between two variables in a dataset. We can ask the AI to generate the R code for this visualization. Let's type in R code to create a scatter plot of age versus income from the dataset. The AI will analyze the prompt and then produce the R code snippet. With clear and specific prompts, we can leverage generative AI to generate code snippets in various programming languages, saving time and effort in our data analysis workflows. Remember, the more precise and context-rich your prompts, the more accurate and relevant the AI's output will be. Erwin, do you have a minute? A project just landed on my desk, and the data set is a mess.
Sure, Ray.
You've been using an AI powered assistant. Is there anything like that for data cleaning?
Oh, yes, AI tools can save you a ton of time.
That sounds amazing, but I'm not sure how to use them.
I can show you. AI tools are user-friendly and they can handle a variety of data cleaning challenges. Let's start here. You can ask the AI tool to standardize the dates.
So I just tell it what to do, and it'll handle the cleaning tasks for me?
Exactly, but be precise when working with an AI assistant.
How so?
Well, instead of just asking the tool to fix the dates, specify your desired format.
So the more specific my instructions, the better my results will be.
Exactly. Now, if there are missing values, the AI can intelligently fill them in based on patterns it discovers in the data. Or you can provide specific instructions on how to handle them.
So I could tell it to delete columns with too much missing data?
Absolutely. But always double check the suggested changes or the code the AI generates.
I'll check to see if anything jumps out as odd or inconsistent. Maybe check a few rows manually to be sure the cleaning was done right.
Good idea. And you may need to rephrase your instructions or add more detail to get the code you need for a task.
Like having a conversation with a helpful colleague.
Yep, the clearer you are, the better the AI can assist you.
Wow, this tool cleans the data much faster than I could. I've even defined some custom cleaning rules to automate the cleaning process for future data sets. Erwin, that AI tool is incredible.
I told you.
Thank you for your help today. That would have taken me days of manual work, and it's already done.
My pleasure, Ray. Glad I could help. Now you can focus on the fun part, analyzing the data and uncovering those valuable insights.
In the traditional world of data analysis, the path to meaningful insights is often filled with complex and time-consuming data transformations. These tasks, while necessary, can slow you down and make it harder to get value from your data quickly. But with generative AI, a new way of processing data is possible. By the end of this video, you'll be able to describe how generative AI simplifies the process of data transformations and makes it easier to handle and interpret complex data sets. And you'll be able to explain how to leverage AI for routine tasks and enhance data processing efficiency. Imagine effortlessly transforming your raw data into a structured analysis-ready format with just a few simple commands. Generative AI, with its ability to learn from your data and understand its patterns, acts as your helper, automating many of the tedious and repetitive tasks that used to take up your valuable time. Your first step should be to familiarize yourself with the wide variety of generative AI tools available. From libraries and frameworks to user-friendly platforms, there are many options designed to meet your specific needs. Explore these tools and find the ones that fit best with your workflow. Once you've chosen your tools, you'll find that data transformation becomes much easier. Instead of struggling with complex code and formulas, you can interact with your data using natural language commands. Simply describe the transformations you want, and the AI model, with its knowledge of data structures, will execute them perfectly. Let's look at an example. Suppose you're working with a dataset containing customer information, including customer ID, city, purchase history, and demographic details. Your goal is to divide your customer base into groups based on their purchase behavior and demographics, so you can create targeted marketing campaigns. Traditionally, this task would involve a series of manual data manipulations, including filtering, sorting, aggregating, and joining various tables. You'd carefully write SQL queries or Python scripts to get the results you want. This process, while possible, is prone to errors and can be time-consuming, especially with large and complex datasets. But with generative AI, the process becomes much simpler. You state your intentions, such as segment my customers into groups based on their total purchase amount and age. And the AI model, understanding your data, quickly performs the necessary transformations. In no time, your data is segmented, revealing distinct customer groups with unique characteristics. You can customize your marketing campaigns for each group, leading to more effective campaigns and improved outcomes. The time you save using generative AI for this task can be used for more strategic work, like analyzing campaign performance and improving your marketing strategies. Generative AI can also automate many of the routine tasks that take up a lot of your time, from data cleaning and formatting to generating reports and visualizations. Generative AI models can handle these tasks efficiently. When you receive a new dataset filled with missing values, inconsistent formatting, and outliers, you can spend hours cleaning and preparing this data for analysis. With generative AI, you can automate much of this process. You simply give the model instructions on how to handle missing values, standardize formats, and deal with outliers. The model, with its ability to learn from your data and identify patterns, executes this task smoothly, giving you a clean and structured dataset ready for analysis. Generative AI can also make it easier to create reports and visualizations without the need for manual coding and formatting. You just describe the kind of report or visualization you want, along with the relevant data and metrics, and the AI model creates it instantly. You can customize the output to match your branding and style, ensuring that your reports and visualizations are both informative and visually appealing. But the benefits of generative AI don't stop there. It can also help you work with complex datasets more easily. With its ability to handle large amounts of data and find hidden patterns, generative AI can reveal insights that might otherwise be missed. Think about analyzing a huge dataset with millions of customer interactions across multiple channels. Manually going through this data to find trends and patterns would be a huge challenge. But with generative AI, you can use its computational power to process this data quickly, uncovering valuable insights in a fraction of the time. The AI model can identify recurring themes in customer feedback, find problem areas in the customer journey, and even predict future customer behavior based on past data. With these insights, you can make informed decisions about product development, customer service, and marketing strategies, leading to happier customers and business growth. By automating routine tasks, simplifying data transformations, and helping you handle complex datasets, this technology can change the way you work. As you start using generative AI in your workflow, you'll find that you can achieve more in less time, gain deeper insights, and have a bigger impact with your data.
All right, AI Assistant. I'm working on a project to predict future stock prices. Accuracy is crucial, but I also need to deliver results quickly. Can you help me achieve both?
Of course, Ethan. Let's build a predictive model. Here's a Python code snippet using a time series forecasting algorithm.
This looks good, but we can make it more robust. Let's explore some additional features that might improve the model's accuracy. Can you incorporate sentiment analysis of financial news articles or social media data?
That's a great idea, Ethan. Sentiment analysis can provide valuable insights and may improve the model's predictive power. I can generate code to fetch and analyze relevant news and social media data.
Perfect. Now, let's make sure this model can handle unexpected market events.
I can help you implement techniques like outlier detection and adaptive learning. That could make the model more resilient to sudden shifts.
That's much better. Now, the model feels more reliable and adaptable to real-world conditions. Thanks for the quick update.
My pleasure, Ethan. It's always a good idea to review and refine the code.
It looks like the model consistently predicts higher returns for tech stocks compared to other sectors. Could there be some bias in the data or the algorithm?
That's a valid concern, Ethan. It's possible that the historical data we used for training gives more weight to large tech stocks or over a more limited time frame than expected.
What are some strategies we could use to mitigate that bias?
We could try collecting more diverse training data from a wider range of industries and company sizes.
Good. Let's see how that impacts the model's predictions. Can you generate code to scrape financial news and social media data? Start with a focus on companies in the renewable energy and healthcare sectors.
Of course, Ethan. I'll get right on that.
Thanks to the AI assistant's help, we were able to develop this model in record time and achieve a high level of predictive accuracy. This will allow us to make more informed and timely investment decisions. Working with an AI assistant is a partnership, combining AI-powered analysis with human judgment for a winning combination.
Let's explore the powerful partnership between humans and AI. By the end of this video, you'll be able to describe the importance of human-AI collaboration in the code generation process, and you'll be able to explain how to address potential challenges and strategies for establishing an effective partnership. Generative AI can produce code snippets, automate repetitive tasks, and even offer insights based on patterns it identifies. So why is your partnership with AI so important? Well, AI isn't perfect. It might misunderstand the context, make logical errors, or even generate code that's technically correct but isn't the most effective. Your domain knowledge, critical thinking, and problem-solving skills are important in guiding the AI, refining its output, and ensuring the generated code is accurate, efficient, and aligned with your specific goals. Imagine you're working on a complex data visualization project. You could spend hours writing code, or you could leverage generative AI to generate a basic structure. From there, you fine-tune the code, add custom elements, and ensure the visualization tells the story you want it to. This collaboration comes with its challenges. AI models are only as good as the data they're trained on. If the training data is biased or incomplete, the generated code might reflect those flaws. Let's say you're analyzing customer churn data. AI can quickly identify patterns and correlations, but it might miss subtle nuances or underlying causes. Your understanding of customer behavior and market trends allows you to interpret the AI's findings, uncover hidden insights, and develop targeted strategies to reduce churn. This collaborative approach leads to more actionable and impactful solutions. That's why it's important to establish an effective partnership with AI. Your first step should be to clearly define your objectives and communicate them to the AI. The more specific you are, the better the AI can understand your needs and generate relevant code. Next, provide the AI with context. Share relevant information about your project, data sources, and desired outcomes. This helps the AI make informed decisions and avoid generating code that's out of context. Remember, AI doesn't have your intuition or experience. It relies on you to provide the necessary background. Once the AI generates code, review it carefully, looking for errors, inconsistencies, or potential improvements. Think critically about the code's logic, efficiency, and maintainability. Don't be afraid to challenge the AI's output or request alternative solutions. This iterative feedback loop is key to refining the AI's performance and ensuring the generated code meets your standards. To illustrate, let's say you're tasked with building a predictive model. You could use AI to generate a basic model structure, but it's your responsibility to select the appropriate algorithms, fine-tune the hyperparameters, and validate the model's accuracy. You might also need to interpret the model's output and communicate its implications to stakeholders. These tasks require human judgment and expertise that AI can't replicate. Another challenge is the potential for over-reliance on AI. It's easy to let the AI do all the work, but this can lead to complacency and a loss of critical thinking skills. Remember, you're the expert, not the AI. Use it as a tool to augment your capabilities, not replace them. Establishing an effective human-AI partnership requires ongoing communication and collaboration. Provide feedback, ask questions, and challenge its assumptions. The more you interact with the AI, the better it understands your needs and preferences, leading to more accurate and relevant code generation. In addition to communication, cultivate a culture of learning and experimentation. AI is constantly evolving, and new techniques and models emerge regularly. Stay curious, explore new possibilities, and embrace the learning process. The more you invest in your own development, the better equipped you'll be to leverage AI's full potential. Now, let's address some common misconceptions about human-AI collaboration. Some people fear that AI will replace human data analysts altogether, but this is far from the truth. AI is a powerful tool, but it lacks the creativity, intuition, and critical thinking skills that humans possess. The future of data analysis is in the collaboration between humans and AI, not the replacement of one by the other. Another misconception is that AI is only for experts. While it's true that some AI tools require technical expertise, many user-friendly solutions are available. As you continue working with data analysis, keep some key takeaways in mind. Human-AI collaboration isn't about replacing human analysts, but about enhancing their capabilities. To achieve this, effective communication, clear context, and constructive feedback are crucial for successful collaboration. By cultivating a culture of learning, experimentation, and adaptation, and viewing AI as a collaborator rather than just a tool, data analysts can understand the full potential of this partnership. The future of data analysis belongs to those who excel at human-AI collaboration. With these principles in mind, you're well on your way to becoming a leader in data analysis. So explore, create, and innovate. Use your imagination and the potential of human-AI collaboration. Let's explore how human expertise and artificial intelligence work together when it comes to writing code. By the end of this video, you'll be able to compare code snippets generated by AI with code written by humans and describe their differences in style, efficiency, and potential errors. This will also help you understand why it's so important for humans to review AI-generated code. AI models trained on huge amounts of code can now generate functional code snippets based on your instructions. This can speed up the development process significantly, offering quick solutions for common coding tasks and a helpful starting point for more complex projects. However, it's important to understand that AI-generated code, although often functional, may have some quirks. It might be hard to read, or prioritize being short over being clear. Also, even though AI models are getting better, they can still make mistakes. This is where human review comes in. You, as a data analyst, have specific knowledge and critical thinking skills that AI can't match. By carefully checking AI-generated code, you can spot errors, make it more efficient, and ensure it fits your project's needs. Think of it like this. AI gives you a basic sketch, but your expertise turns it into a finished drawing. You add the details that make the code not just functional, but also well-organized, easy to understand, and adaptable for future use. When you're reviewing AI-generated code, there are a number of things you should pay attention to. The first is style and readability. Is the code well-organized and easy to follow? Are the variable names clear? Does the code follow standard coding practices? Remember, code is read by humans too. Then there's efficiency. Does the code do its job in the best way possible? Are there any unnecessary calculations or steps? Sometimes AI may choose a less efficient method to complete a task. There's also error handling. Does the code handle errors well? Are potential problems caught and dealt with properly? AI might not always predict every possible issue. Also, consider security. Does the code follow security best practices? Are there any weaknesses that could be exploited? AI might not always prioritize security. Finally, pay attention to maintainability. Is the code well documented and easy to change later? Will other developers understand it? AI-generated code might not always be easy to maintain in the long run. The goal isn't to just accept or reject AI-generated code. It's to work with it, using its strengths and learning from its weaknesses. In the end, you want code that works well and reflects your understanding of the problem. Let's look at an example. You're analyzing customer transactions and using AI to generate code to calculate the average purchase amount. We begin by importing the pandas library, giving it the alias PD. Then, we use pandas to read the transactions.csv file into a data frame named df. We calculate the average of the purchase amount column and store it in a variable called avgPurchase. Finally, we print the result. While this initial code snippet appears functional, it has room for improvement in several key areas. First, it lacks robust error handling, assuming the file and column exist and contain the expected data types. This could lead to crashes if these assumptions aren't met. Second, the variable names could be more descriptive, enhancing code readability and maintainability. Lastly, while suitable for smaller datasets, this approach might not be the most efficient for handling very large datasets, potentially leading to performance bottlenecks. Here's the improved code. This improved code snippet first tries to read the CSV file, but if it's not found, it prints an error message and stops. Then it checks if the purchase amount column exists and contains numeric data. If there's any issue, it prints an error and stops. Finally, if everything is okay, it calculates and prints the average purchase amount. Error handling, clear variable names, and considered efficiency have been added. This shows how human review can turn AI-generated code into something robust and high quality. Let's go over a few additional points to remember. AI models are constantly learning and improving. What might be a limitation today could be addressed in future updates. Stay informed about the latest advancements in AI code generation. While AI can generate impressive code snippets, it's your human expertise that brings true understanding and context to the code. You ensure that the code not only functions correctly, but also aligns with the specific goals and nuances of your project. View AI as a collaborator, not a competitor. By working together, you can use the strengths of both human intelligence and artificial intelligence to achieve remarkable results. As AI continues to evolve, so too should your skills and knowledge. Stay curious, explore new tools and techniques, and embrace the opportunities that AI presents for enhancing your data analysis capabilities. In data analysis, the combination of human expertise and AI assistance holds immense potential. By using AI code generation and applying your critical thinking and domain knowledge, you can elevate your work, streamline your workflows, and unlock new levels of efficiency and insight.